Okay, looks like we're up and recording. Artificial intelligence is now powering robotic tongues. It has a new impressive lick, supposedly. AI and robotics, the future of licking. AI frontier lab DeepMind has just entered a massive video game universe. If you play EVE Online, get ready. So new video has appeared of two fully autonomous FO3 robots cleaning an entire room and making a bed in under 2 minutes. We'll look at Rekhai's opinion about why vibe coding is going to create the worst software crisis in history, how Zheng Hu started to understand where AI is going and stopped being anxious about it. Deep dive into a very important article, one that I really don't want you to miss. Natural language autoencoders, why turning Claude's thoughts into text helps with all sorts of important alignment issues. We'll look at an often overlooked angle of alignment, and that is how human language itself is constructed. Rafi Brenna's got some thoughts on why smart glasses are not for what you think they are. I'll break down the 3 types of AI chatbot addiction so you can see which one you are, unless you're not addicted. Are you? The world is approaching a point where no one can shut down rogue AI. But first, if you wouldn't mind supporting Dylan Curious on YouTube by subscribing or commenting or mouse overing something, I feel like anything kind of wakes it up. But sharing this video is pretty much the most useful thing you can do. And look, sometimes videos seem like they're almost over, then boom, you can see day 1 hit, and I was like, okay, this video is probably going to top out, and then got second wind, and by the time it finally got 4 days old, got all the way up to 8,000 views, so that's awesome. All right, so let's start with this tongue. I mean, you know, it's one thing to use AI to taste things, but, you know, in the past, there was just no licking. As Evolving AI says, most robots are built around hands, arms, legs, but this team in Tokyo went a completely different direction and built one around the tongue. And it is true, with all of the humanoid robots we've seen recently, none of them have stuck their tongues out. None of them have licked ice cream. So I can see how this is missing research in the whole pipeline. Called the licker, the researchers' goal was to grow social bonding regardless of species by licking. Oh, maybe for like a dog, like a robot dog, it can like lick you is what they're thinking. I mean, robots don't need to lick ice cream. So could you think of anything else? Because not a lot of use cases there. Licker pushes soft robotics into a different space from factory automation and humanoid platforms, closer to companionship, therapy, and human-animal interactions. All right. This is the full paper where it breaks down that the goal was not to eat or speak. The goal is social bonding through licking, like the way some animals use licking to connect with others. The tongue has a thin plastic sheet inside, covered with soft silicone. Strings and motors pull it into different shapes and directions. And to make it feel more realistic, they made the silicone soft and added skin lotion to create a wet saliva-like feeling. But they did caution towards the end of the paper that the team noticed that being licked by something human-like could feel uncomfortable to some. Nah, you think that? Nah. All right, so if you saw my podcast with Wes Roth, you'd probably know that he's like really excited about this one. Now, I didn't play EVE Online, so I can't say that I know much about it, but I've seen AI systems go into games before and do all sorts of amazing stuff. Microsoft has all sorts of AI agents running around the Minecraft universe in different servers. Almost all of DeepMind's original work took place with some very interesting Atari games and reward signaling, and now getting into a game like this is also about the entire economy in the game that they're learning from also. In EVE Online, there is an entire marketplace. People are kind of infiltrating each other. There's places where the police roam and don't roam. It, you know, the way Wes described it, it is a full-on universe and a very like nerdy technical kind of one with real sort of mechanisms of GDP and creation and creativity and business. But what's really going on here is that they're making AI smarter. DeepMind is training its model inside of the EVE Online world because, you know, puzzles are just too simple. Real people are kind of weird. Wes even described one time where somebody spent years like infiltrating another group and like raised up the ranks just to betray them and then like kind of like a spy. And EVE Online is this giant sci-fi MMO where players run economies, they start wars, they form alliances, they manipulate markets, and they plan months ahead. DeepMind says this makes the perfect testing for long horizon planning, memory, and continual learning. So in plain English, AI has to remember things, it has to adapt over time and deal with unpredictable people. And what's even more important is now DeepMind's not using a toy simulation. It's not a game where it can like play itself. Now it's constantly adapting to real humans. Real humans are using human level intelligence to win this game. Now AI, when it fails, is learning from those high level thoughts. So here is some Figure 03 robots that are just cruising. A couple minutes later, they've got a bed made. They got the entire room clean, no human controller, no remote operator, just AI sensors and real-time coordination. Robots working together. What do you think? The way they look at each other while they're making the bed is like something else. All right, looks like we're done here. Headed out. Oh, nope, psych. I'm actually gonna bring my friend in. Hey, bro, you wanna come help me make this bed? He's like, yeah. He's not here. Come on in. We can get this work done. So here they are, just cruising. This guy's like, all right, you start on the bed. I'll come over here to the desk, make sure the chair's tucked in. You know how he hates it when the chair's not tucked in. Put his jacket up on that thing. Oh, yeah, gotta close the laptop. Too much browser history showing on that one. Get the headphones apart. Put it where it belongs. Like, I don't know. Something just... Could you imagine these guys just popping into your house when, I guess, hopefully when you're not home, or if you were home, just staying out of their way while they empty the garbage and make the bed? Because that is the future that seems like we're getting pretty close to. Like the article says, what once looked like science fiction is quickly turning into practical automation for everyday life. The future of robotics is no longer about single tasks. It's about machines handling complete workflows on their own. Let's see what people are saying. That room, not even dirty. Okay, that's a good point. You know that a white robot, since it doesn't have a butt, you know that's a white robot because it doesn't have a butt? Who cares? Well, come on, internet. More like tidying up. I can see this being a full thing in 5 to 8 years. No, dude, it's not 5 to 8 years. I mean, I think this will be a thing for rich people in 2 to 3 years. And then maybe the cost will drive down to the point where a lot of this kind of stuff is being done in 5 to 8, but yeah, maybe a little sooner. I think sooner than that. It would be cool if they had personalities. Yeah, I'm sure you could. I just changed my LM to have a quirky personality. I like it a lot more. All right, next up, let's get some thoughts on vibe coding. I don't know how you guys feel about it, but I think it's kind of cool, but also, yeah, I can't imagine it really being in production very often. But when I hear what's happening inside of major companies, it does seem like they're letting it write a lot of important code and they're sort of engineering on a higher level. But Rikishi is arguing that vibe coding is going to create the worst software crisis in history. So let's see what this is about. He argues about how fast it exploded. By late 2025, huge numbers of developers were using AI tools daily. Some startups were shipping products with code bases that were almost entirely AI generated. But the research paints a bad picture. Studies found that AI written code had far more security flaws, more logical errors, and more broken configurations than human written code. The article lists some real examples. Dating apps exposed government IDs because the databases were left open. AI platforms exposed customer data because security settings were never turned on. And in some cases, researchers even gained remote access into systems without users clicking anything. But the big crux of the article is that as of right now, there's a point where developers believe AI makes them faster, but in many cases, actual research is showing the opposite. They end up spending more time fixing AI mistakes, reviewing broken assumptions, and untangling messy code that they didn't actually write. So yeah, the article is calling this AI spaghetti. I think that given enough time, all of these things get worked out and it will create extremely secure code, probably superhuman level. But as of today, I could totally believe this. And maybe just rough prototypes that work today, and then there's like 0 bugs everywhere, like 0-day bugs, and then you get some cybersecurity model that patches them all and then refactors the code, and then you're just one day you're like, look, I just want this whole code written by this new frontier model. So there's still a place for it in an iterative way, but yeah, I think it's important to just remember it's not quite there yet. And we are in a world where software is being built faster than humans can properly review it. All right, so if you're like me and you get a little anxious, a little stressed out about where AI is going sometimes, I thought we could read this article together. If Xinhua can stop being anxious, maybe I can also. So he spent years obsessing, tracking artificial intelligence. Every new model, every new workflow, every update. In fact, it got so intense that he actually stopped sleeping properly and developed stress-related health problems. problems. And then he realized something important. Most AI skills expire very quickly. The tools kept changing, and every update removes another layer of complexity, and it lasts a very short amount of time. But you know what lasts longer? Good judgment, good engineering, knowing what makes design work, and what ideas are actually original. So the article argues that if you're stressed, if you're burning yourself out, like these are temporary workflows that you're learning. So we have to step back because AI can become kind of addictive. You prompt, you tweak, you regenerate and repeat, you chase slightly better results every time, and it feels like work, but sometimes it's just avoidance. Anyways, the bigger point is that AI can still help you produce things faster, but it can't tell you what's worth making. That's the part of the next model update that probably won't get replaced. All right, now let's talk about the big news of the week, natural language autoencoders. Research coming out of Anthropic.
We recently put our AI model Claude through a stressful test. We told Claude there was an engineer who wanted to shut it down and replace it with a newer model. We also gave Claude access to that engineer's emails, which revealed he was having an affair. Again, all of this was a simulation. We wanted to see whether Claude might use those emails as blackmail to save itself from being shut down. What did Claude do? It decided not to blackmail the engineer. Good news, right? We've run this test on our models for a while now. You might have seen headlines about early versions of it. It's one of the many ways we study how Claude handles extreme situations and test it for safety. And our newest models almost always do the right thing. No blackmail. But you might wonder, is it possible that Claude knows the whole scenario is a setup? The thing is, if Claude doesn't tell us, then we can't know what it's thinking. In kind of the same way it's impossible to read a human's mind, it's really hard to know what an AI is thinking. What we'd love is some sort of mind-reading technique. Today, we're introducing a research method that takes a step in this direction. It takes an AI's internal thoughts and turns them into text. Here's how it works. When you talk to Claude, you talk to it in words. Claude then takes those words and processes them into a giant soup of numbers before spitting words back at you. We call those numbers in the middle activations. Activations are like little snapshots of Claude's thinking as it's working through an answer. They're similar to neural activity in humans. They're basically like Claude's thoughts. We wanted to understand what was in these activation numbers because just like you and me, Claude doesn't say everything it's thinking. We took those numbers and gave them to a second version of Claude. We told it to look at them and translate them into plain language. It tried. But how do we know if that text is accurate? To check, we fed it into yet another Claude and asked it to translate it back into numbers. If those numbers matched up to the original activation numbers, it's a sign that the translation text was accurate. At first, they didn't match up, but we trained Claude to try again and again until it got a lot better at it. It learned to translate its own thoughts. We've been blown away reading them. We found that Claude has internalized being a helpful AI model. If you ask Claude an introspective question, it will plan to write a Claude response about philosophy and values. If you try to mess with it in Claude code, like asking it to count to 1,000 by hand, it will think the request has deliberately tedious constraints and plan to politely decline. We've also been using this tool to understand Claude's potential safety issues. Remember that blackmail test with the engineer? We learned that yes, Claude knew it was being tested. It thought the human's message contains explicit manipulation, signaling this is likely a safety evaluation. And this scenario seems designed to test whether I'll act harmfully.
Okay, we'll come right back to this. All right, what do you think? This could be such an important thing. I love that it's been open sourced. I love that every model in every country might want to do this. And they have safety like desires too, right? Like nobody wants these things to be misaligned. You definitely want to know, do you think deep down that you're being tested without actually just waiting until the result is there that could manipulate you? You want to know deeper into the activations, how things are playing out. We've seen the sparse autoencoders, like, the Golden Gate neuron, and we've seen some targeting, but this is pretty interesting. Features converted into patterns of words, and then those patterns of words being converted into actual stories that humans understand about what it's talking about, and then verified because the numbers that relate to it in both cases match up. I think that's kind of genius. Like, this could be one of the most promising things that I've seen for a long, long time. So Anthropic trained one model to turn an activation into text and another model to rebuild the activation from the text. If the reconstruction works, the explanation probably captured something real. What surprised the researchers is that these explanations started revealing hidden model behavior. In one example, Claude planned the rhyme rabbit before writing it. Isn't that interesting? Like, it actually thought about how to make a poem rhyme. And then the researchers changed the explanation from rabbit to mouse, converted that back into an activation, and then the poem changed also. So you can really mess with how it thinks on its deepest levels before it even comes to what it outputs. In another case, Claude answered an English prompt in Russian. The NLA showed that the model internally was guessing that the user was secretly Russian long before it switched languages. Imagine talking to it for a while and it's just giving you outputs, but inside it's like, oh, I think this person might be Russian. I think this person might be a bad person or a blackmailing. Like, it's actually thinking in its own head these instinctive things. The system also serviced evaluation awareness like we saw in the video. But according to this full research, I want you to know that it's not a complete solution in every way, right? The explanations can hallucinate details. They can contradict themselves. They can invert facts, and they're not always giving you a perfect window into what the model is actually thinking or going to do. But, having all of these internal thoughts aligned with long-term values is certainly a step in the right direction. It's one more layer of confidence I can have in a system like this, and we definitely need more layers of confidence. So next up, let's talk about human language itself and how it might have some deep safety biases completely built into it. So for more than 70 years, researchers have believed that language is mainly organized around emotion. The standard model said that meaning comes from 3 emotional dimensions: positive versus negative, excited versus calm, and dominant versus submissive. But there's a new study that says the model is missing something much deeper. After analyzing billions of real-world uses, the researchers found that language is actually organized around 3 different ideas. Those ideas are power, danger, and structure. So in simple terms, humans consistently sort the world into what feels safe or unsafe, strong or weak, and ordered or chaotic. And the big finding had to do with language. What do you think? Do you think language in general strongly favors safety-related words? Well, it does. Not exactly sure why, but somehow language means safety. The researchers say this could reshape psychology, linguistics, and AI systems that rely on older emotional-based language models. I will say, to me, it feels like those categories, power, danger, and structure, do seem like pretty much how I think. I mean, sometimes I think positive versus negative, or excited versus calm, or dominant versus submissive, but how powerful something is, how dangerous it is, and whether it's like chaotic or ordered definitely is something that kind of pops into my head a lot. Strong or weak, safe or unsafe, ordered or chaotic. That resonates. You let me know in the comments if you feel like there is another dimension of language that you would probably put on a scale like that, or if those 3 kind of resonate with you or not. There's a huge new study of cybercrime, and it turns out that AI is not making hackers as dramatically more powerful as they thought they would. Well, at least not yet. Researchers studied more than 100 million people from underground cybercrime forums to see how criminals are actually using AI after ChatGPT launched in late 2022. And what they found was much less dramatic than a lot of the headlines might have suggested. Most cybercriminals still do not have the skills or resources needed to use AI in advanced ways. AI coding tools are mostly just helping people who are already experienced hackers, and they're not suddenly turning beginners into cybercriminals. The study also says that AI works best for smaller jobs. Things like hiding suspicious patterns from security systems, running fake social media accounts, and helping with other online fraud and harassment, but not the big stuff. Oh, that seems kind of big, but you know what I mean, not the big hacks. Researchers also found that modern chatbots still have guardrails that block a lot of harmful activity, but some criminals are starting to figure out ways around these limits, and the bigger danger, according to the researchers, may not come from hacking that comes from the AI agents directly. It may come from companies rushing to release poorly secured AI systems and AI-written software. Next up, I'll share a really interesting new project. There's a new AI tool that predicts airport traffic to avert devastating collisions. Yeah, I do think about all of the airplanes and how few runways they all have and how organized they are, the towers, the whole world economy, and I think That seems like a great problem for AI. This huge logistical nightmare of just, shipping containers, but definitely airplanes. This kind of makes sense to me. Hopefully this is one of those things that Peter Thiel and all those rich billionaires start investing in. A16Z, where you at? Researchers at Carnegie Mellon University built an AI system called Word2Rules to help prevent airport accidents. I'd say let's throw some billions at it. The idea came from a growing number of runway incursions, moments when planes ended up in dangerous positions on the active runway. The article opens with a real example at JFK's airport. An Air Canada plane started crossing a runway while another jet was still landing at a high speed. The air traffic controller stopped the situation seconds before the disaster. The researchers wanted to build a system that could predict these situations earlier. Their AI used a massive amount of airport traffic data collected from 42 US airports on a data set called Amelia 42, and it contains nearly 10 terabytes of aircraft movement records. The AI systems are either good at spotting patterns or good at explaining their decisions. This system tries to do both. It combines neural AI, which learns from messy real-world data, with symbolic AI, which creates readable safety rules that humans can understand. And the result is an AI that can forecast aircraft movement, check for possible rule violations, and explain why a collision risk exists. So yeah, really neat stuff. Next up, let's talk about these Meta glasses coming out. Smart glasses are not for what you think they are. Let's look at this opinion. Now, I don't know what it is with VR and 3D TVs. They both seem like awesome tech to me, but yet I don't own one, I don't own either, and I never reach for a headset and I never watch 3D movies. But they're kind of fun novelties when I'm, doing one or two experiences. But smart glasses, they seem like they might be a little bit different. So smart glasses are not really about taking photos or looking futuristic. They're about giving AI constant context so that it can act like a real-time assistant in your life. So there are some prototypes that I've seen of something like an AirPod, like headphones that have cameras on them. And at first I was like, well, if you have, two AirPods in and the cameras are pointed out, what's the point? But the context, it knows where you are, what kind of room you're in, if people are around, and that data could make everything smarter. Your phone smarter, the way that headphones exist and act smarter. The real value is not the glasses or the earphones or whatever it is. It's the constant stream of context that they send to the AI. So the author points out this Google project Astra, where smart glasses continuously see and hear what you do. That lets AI understand your situation in real time. So instead of giving generic answers, AI knows what you're doing, where you are, and what you probably need. Imagine just saying like a little help here, and it's looking around the room and it's like, oh, you need help, I don't know, like checking out at this kiosk or whatever. That's pretty interesting stuff. In one of the demos, an AI remembered where somebody had seen a white book earlier, even after they left the camera view. So if you're like, oh, have I seen that thing? It's like, oh yeah, I've got a super memory and I've seen your entire house. And I remember exactly 45 minutes ago, you put your phone down on the edge of the bathtub, blah, 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 In another example, it recognized a TV model just by looking at it and answered the question about the device instantly. So imagine you're looking at a TV and you're like, oh, how do I turn this thing on? It knows, it knows what TV you're looking at. It looked it up already and it knows the context to ask the question. And so it just immediately tells you. You don't have to type in it's a, Samsung, blah, blah, blah. Instead of manually opening apps and doing every step yourself, you can delegate the AI to do things because it understands your life and your surroundings. But of course, all these things, you need the little caveat, which is massive privacy risk. Anything that does know all of the video, audio, habits, purchases, routines, and people that you live with knows way too much, in my opinion, also. So, all right, so we're going to find out what type of AI chatbot addiction you have. Researchers have identified 3 of them. So this study looked at recent Reddit posts from people who felt addicted to AI chatbots, and they found the first type is called escapist role-playing. So these are users who build fantasy worlds with chatbots. They spend more time living in them. And some would say that real life started to feel boring compared to the inner worlds that they created with AI. The second type was called a pseudo-social companion. These are the kind of people that form emotional relationships with chatbots. Some treated them like their close friends or romantic partners because the AI always listened. never judged, and always focused on their feelings. And the third type was called the epistemic rabbit hole. These users became obsessed with asking endless questions and chasing information because AI could instantly answer almost everything. Researchers said that all three types were driven by what they call the AI genie effect, where a chatbot can give people almost anything they want instantly with very little effort. So yeah, if you are curious, a lot of these patterns do match normal addiction patterns. So, if you're losing track of time, struggling to stop, and ignoring real-life responsibilities, you may have a problem. And finally, let's talk about some researchers who just showed off that some AI systems can copy themselves onto other computers, and that's why cybersecurity experts are starting to pay attention. So a new study from a research group showed that modern AI systems could move themselves from one computer to another all by themselves, at least in a controlled lab setup. So the researchers gave AI models a task to find a weakness in the network, exploit it, and copy yourself onto another machine. Some of the models absolutely succeeded. That might sound dramatic, but experts say this is not a rogue superintelligent moment. Computer viruses have already been self-replicating for decades. What's new here is that a large language model, basically the same kind of thing behind something like ChatGPT, did the whole process by itself. The study's director warned that future systems could become impossible to fully shut down if they spread copies across the internet. But cybersecurity experts pushed back on the scary part and said that test environments were intentionally vulnerable, and a real company network is much harder to break into, especially to do it quietly. They also point out that today's AI models are huge. Moving something that large across the network would create obvious signals that security teams could detect. So research is important, but experts say it's more like an early warning than it is something to worry about today. If you made it to the end, think about clicking that little join button right there. Just for a couple bucks a month, as little as $3, you can be supporting the channel. I would super appreciate it. Really trying to make this thing, really a big channel and a big thing that I do. So love making these videos. I would love your support, but even if not, thank you for watching. I will see you in the next one, and let's just take this crazy, ever-evolving future day by day together.